If you've been struggling to figure out how to convert between degrees and radians, and you feel like you're not making progress, you've come to the right video because I'm about to show you how to do it in just under a few minutes, like a ninja. Let's get started. Hey everyone, let's talk first about degrees. You've all seen the Cartesian plane, where if I give you a coordinate at xy, and you want to find out the angle it makes with the origin, you would plot that point on the xy coordinate system and draw a line from the origin to it. That would give you a height of y, a base of x, and a hypotenuse for that right triangle of r. And then you can use your sine and cosine trig functions to determine what the angle theta is. For example, if you know what x and y are, like given above, then you can use arc sine and arc cosine respectively. But let's talk about the unit circle in particular. What do I mean? Because when we are dealing with degrees above, we're talking about the interior angle that this triangle is making with respect to the origin. But with the unit circle, it's a little bit different. This is going to help you to understand radians. Because when we're talking about radians, you have to understand how the unit circle works here. With the unit circle in particular, the way it's different from a general circle when you draw it is that the radius happens to be 1. And if we know that the circumference of a circle is 2 pi times r, the radius, and r is 1 in our case, then your circumference here is 2 pi. And we all know that the interior total degrees that a circle makes, if you were to fully trace it, would be 360 degrees. And that's a really important point for our conversions that we're going to do below. And before I go on, if you haven't already, hit that subscribe button, drop a comment in the chat below. Let me know how your pre-calculus experience is going and what topics you'd like me to cover. So to recap, degrees are talking about the interior angle in the xy coordinate system. And then when we're going to talk about radians, what's really important is we're dealing with tracing the outer circumference of a circle. So if you look at this unit circle right here, I want you to think about, instead of an inside angle, how much of the outer circumference have you traced when dealing with radians? Now, I already mentioned that the entire interior angle of a circle, when you fully were to wrap around it, would be 360 degrees. And we also know for the unit circle that because the radius is 1, the circumference is 2 pi. So a really important property we can make here, which is your first conversion step, is that 360 degrees equals 2 pi radians. And again, when we're talking about radians, we're talking about the unit circle and tracing the outside. So if 360 degrees equals 2 pi radians, you can divide both sides by 2, and you'll get that 180 equals pi. And we're going to use that ratio to convert between our units. I went ahead and redrew the unit circle here, but also with an interior angle called theta. And what I want you to notice is that at these different points on the XY system, I'm showing you the degrees you get, right? So if theta were to reach to the very right and stay on the x-axis, you would get either 0 degrees or 360 if you happen to do a complete circle around. And if you were to convert that to radians, I wrote that in pink, 0 degrees would be 0 radians, and 360 degrees would be 2 pi radians. Going to the very top at 90, that 90-degree conversion would be pi over 2 radians, and you get the point. Now, the 180 and the 360 might be a little bit more clear to you because we talked about it above. But for 90 degrees and 270 respectively, how did I get pi over 2 or 3 pi over 2? Let's talk about that conversion because that's why you came to this video. So we know that 360 degrees is the same as 2 pi radians, or simplified when dividing by 2, 180 degrees is the same as pi radians. So anytime I give you an angle in degrees, you can just multiply it by pi over 180. And why is that? Well, when we're talking about radians, that is a unitless figure. 2 pi, 3 pi over 2, etc. You don't have degrees at the end. So loosely speaking, you can think about if the numerator here has a unit in degrees and the denominator has a unit in degrees, they basically cancel out. So given any degree, you would just multiply it by pi over 180. And if you go in the reverse, it's the same idea, with the difference being that if I give you something in radians, now you just flip the fraction that you're multiplying it by. So 180 degrees over pi versus pi over 180. And then what if I actually change it up? Well, what if the radians I give you are negative? Say I gave you negative pi. then you're just changing your tracing direction on the xy coordinate system, because when we're dealing with positive radians, like say pi, pi over 2, etc., we are going in a counterclockwise direction. So with a negative angle, you're going in a clockwise direction. So for example, if I gave you negative pi, we would start at the origin and go clockwise, and we would get to 180 degrees. And guess what's kind of cool there is you get the same thing if you get pi radians. Now what about negative pi over 2? Well, now you're just going in the opposite direction 90 degrees. So negative pi over 2, as you can see, would have you ending up at 270 degrees. So it's kind of like saying negative pi over 2 radians is the same, logically speaking, as positive 3 pi over 2. So I hope you enjoyed this video, and be sure to check out this playlist you see on your screen, because I'm going to be uploading more. I'm uploading about once a week, and hope you all have a good day.